Question 16, we have an incomplete histogram with information about the ages of people living in a village. Our frequency density, notice, has no scale here, so that's going to be one of the first things we do, is figure out what the scale is. So we have an incomplete histogram and we have an incomplete table. Now, whenever you've got these types of problems with an incomplete table and histogram, there will be one part of the graph and one part of the table that is complete in terms of each part matching the other. So if we look here, the first bit, 0 to 10, there is no bar there, but 10 to 15 there is. So we have the 10 to 15 bar, which I'm just going to shade in here in blue, and the 10 to 15 row in our table, they match each other. Okay, now our frequency equals the area in a histogram. So 60 is the area of this bar here. Now because it has a width, the bar has a width of 5, with this being 15, the width is 5, and the area is 60, then if we want to know what the height is going to be 60 divided by 5, which makes 12, and that height is known as the frequency density. So the height of that blue bar is 12, which means I can label 12 there. Now if we look closely at the squares, you could kind of figure out what the scale is from that. The fact that we have 12 here, it's not that clear in this picture, but we should have, unless my eyes deceive me, yeah, that's it. We should have, there's like darker lines here. You can't see it on the picture that I've got, but in the actual exam paper itself, there's sort of darker lines here. You kind of got these tiny squares, but then you've got these 5 by 5 darker squares. Now, the fact that we have those lines allow us to then, using 12, get a scale. And generally speaking, it can be decimals, but on this occasion, basically works out that every 2 you go up, or every 5 mini squares gives you 2. And then from that, you can even just think to yourself, well, if that's 2, then each tiny square would be 0.4. Okay, because 2 divided by 5 is 0.4. So anyway, so that gives us the scale that we need, which means we can now figure out the area of both of these and use that information to get the frequencies in the table. So that's these two here that are missing. And then similarly with this row as well as the last two, we can find the frequency densities using that information or the areas, and then as a result draw the graph. So just as a reminder, I'm talking about areas here, but some of you might prefer to just think of it in terms of the formula. Frequency density equals frequency divided by class width. So if you happen to use this formula, or maybe you remember as a triangle, that'll also work. So our frequency density for this first row, we have a class width of 10, 0 to 10, it's 10 apart. We have a frequency of 100, therefore frequency density will be 100 over 10, giving us 10. Next one here are, oh no, hold on, that's the one we get from the graph. 50 to 75 has a width of 25. 50 is the frequency, so our area is 50 over 25, giving us 2 for the height, sorry. And then our width of this group here is 5. 20 is our frequency, our area is 20. 20 over 5 equals 4. So the heights of the first bar has to go to height 10, which means this is going to be the height of that first bar. The second one has a height of 2, which means 5 mini squares up. Oh, I've forgotten how long I went to. 50 all the way to 75. So that'll be to here. That's that second row that I figured out in purple here, and then the last one has a height of 4. So that would be there, 10 mini squares. Okay, using the two bars that I've got in green here, the first one and the second one, our area, if you just calculate the area of them, you can do that, well, you could actually do that in here. So the area is going to be base times height. Our base is 15, in terms of 15 across. Our height is 8, so we end up with 15 times 8, which gives us 120. So 120 is going to be the frequency there. And in the bar below, this one's a little bit trickier because of the scale. If we look really closely, that's halfway in between two squares. So given that this is 4 and this one is 6, as far as our scale here goes, that means that us being halfway in between there is going to be 5. So the height of that bar is going to be 5. The base is 20. So we have 20 times 5 for 100. So 100 is the frequency there. And that's us. We have a complete histogram. We have a complete table. That's part 1 done. Part 2. Oh no, part 1 is complete the use the histogram to complete the table. Part 2, use the table to complete the histogram. Doesn't matter which order you do it in. I kind of did them in tandem there. But yeah, that's it.